Today we're going to start our unit on polynomial functions. In particular, we are going to be starting today by talking about polynomial division. So let's take a look at an example of polynomial division. So you're dividing 3x to the fourth minus 8x squared minus 11x plus 1 by x minus 2. Now, when you do polynomial division, you can write it out just like you would with a long division problem. The one thing you want to keep in mind is if there are any terms that are quote-unquote missing, you want to fill them in. So here, for example, we're missing the x cubed term, right? It jumped from x to the fourth to x squared. So we want something to hold that place. We need a placeholder. So we put in 0x cubed. Now here's the process of doing the division. You want to look at the first term in your dividend and the first term in your divisor and ask yourself, what can I multiply x by in order to get 3x to the fourth? I can multiply by 3x cubed. So I'm going to put that right on top. Now I'm going to multiply 3x cubed times x and then 3x cubed times negative 2. That's going to give me 3x to the fourth minus 6x cubed. After you've multiplied, you're going to subtract, or in other words, you have to change the signs. So this will become minus 3x to the fourth and then plus 6x cubed. And then we can go ahead and add, and if you've done this correctly, that first term should always cancel out because you specifically found 3x cubed so that it would equal exactly 3x to the fourth, and once you subtract, it should cancel itself out. That leaves us with 6x cubed, and then we're going to bring down the minus 8x squared, and then we're going to repeat the process. So now I ask myself, what times x will give me 6x cubed? That's 6x squared. Put that up on top. And then now we multiply. So 6x squared times x is 6x cubed. 6x squared times negative 2 is negative 12x squared. And then now we subtract. So subtract, and we end up with the first terms canceling. And then adding these two, we end up with 4x squared. Bring down the minus 11x. And repeat the process again. So x times what gives us 4x squared? That would be 4x. 4x times x is 4x squared. 4x times negative 2 is negative 8x. And now we subtract, so change those signs. First terms cancel. Combining those, we get negative 3x. Bring down the 1. And then repeat this process again. So x times what gives me negative 3x? That would be negative 3. Multiply, so negative 3 times x and negative 3 times negative 2. So we have negative 3x plus 6. And then we subtract, change those signs, and we get negative 5. So our quotient here is 3x cubed plus 6x squared plus 4x minus 3, and our remainder is negative 5. Now that's polynomial long division. We have another type of polynomial division that's called synthetic division. So synthetic division is a shorthand method, and we use it when the divisor is a first degree polynomial. So for example, if you're dividing by x to the first minus 2. If you're dividing by x to any higher power, you are going to be stuck using long division. All right, so we'll do the same exact example that we just did, but instead of using long division, we'll use synthetic division and see if we get the same answer. So with synthetic division, you write, so you're dividing by x minus 2, so you take the opposite of that, so that's positive 2, and you write it in the upper left corner. And then you write all of your coefficients in a row. And again, same as with long division, if there are any missing terms, you want to put a placeholder in. So that x cubed, we're putting in a 0 for that. All right, so here's how synthetic division works. The first thing you do, you bring that 3 down. Next, you're going to multiply and add, multiply, add, multiply, add until you get to the end. So what do you multiply? What do you add? So you are going to multiply this 3 by that 2 that's in the upper left corner. So 3 times 2 is 6. We write that right under the 0. And then we add. Now do the same thing. So multiply 6 times 2, that's 12. And then add. Multiply by 2, we get 8. And then add. That gives us negative 3 times 2, negative 6. Then add, we get negative 5. So now all you have to do is translate this back into a polynomial. And so because we're dividing by a first degree polynomial, our degree for our quotient will go down by 1 from the dividend. So the dividend was 3x to the 4th. So that means that our first term here, our first coefficient, is going to go with x cubed. So our answer here is 3x cubed plus 6x squared plus 4x minus 3. And then that last one that I've written in a little box in the bottom right there, that's our remainder. So our remainder is negative 5. And this is the exact same answer as we got by doing long division. Let's do another example of synthetic division. All right, divide x to the 5th plus 5x to the 4th plus 6x cubed minus x squared plus 4x plus 29 by x plus 3. All right, so take the opposite of 3, that's negative 3. Put that in the upper left corner, and let's fill in our coefficients. So 1, 5, 6, negative 1, 4, 29. Bring down that 1, and now we multiply and add. So multiply, we get negative 3. Add, we get 2. Multiply by negative 3, we get negative 6. That's 0. And we add. Then multiply and get 0. Add, we get negative 1. Multiply, we get positive 3. Add, we get 7. Multiply, we get negative 21. Add, we get 8. All right, so now we have to translate all these numbers back into polynomial form. So we started with x to the 5th. We divided by degree 1 polynomial, so it's going to go down by 1. So this first coefficient will pair with x to the 4th, and then we go down from there. So x to the 4th plus 2x cubed plus 0x squared minus x plus 7 with a remainder of 8. You can also opt to not write that 0 at all and just write x to the 4th plus 2x cubed minus x plus 7 with a remainder of 8. This next thing we're going to talk about is called the division algorithm. Now this is actually something you already know because you've done division before. Perhaps if not with polynomials, just division with numbers. And really what this says is that if you have one number divided by another, if you were to multiply the quotient with the number you divided by and add the remainder, that gives you back the original, right? So if a polynomial f of x is divided by a non-zero polynomial h of x, then there is a quotient polynomial q of x and a remainder polynomial r of x such that f of x equals h of x times q of x plus r of x, where r of x, which is the remainder polynomial, equals 0, or it has a degree that's less than the degree of the divisor. Now, if you want to think about this in terms of just dividing regular numbers and not polynomials, well, you've actually done this before. So say you take 9 and you divide it by 2. You have a quotient of 4 and a remainder of 1. So what this is saying is that if you were to take those numbers, the relationship between them is that if you were to multiply 2 times 4 and then add the remainder 1, you get back 9. So same thing with polynomials. Now the r of x having degree less than the degree of the divisor, that's similar to division with numbers. Let's go back to the example with 9 divided by 2. You get a remainder of 1, right? So 9 divided by 2 is 4 with a remainder of 1. Now that remainder is smaller than the number you divided by. We divided by 2. And so same thing when you're working with polynomials, but instead of a numerical value, it's the degree of that polynomial is going to be less than the degree of the divisor. Okay, so now let's talk about remainders and factors. So if the remainder is 0, when one polynomial is divided by another polynomial, then we would say that the divisor and the quotient are both factors of the dividend. So you know this is true anytime you're working with any sort of division. If it goes in evenly, we know it's a factor. So same thing with polynomials. If one polynomial divided by another polynomial goes in evenly, there's a remainder of 0, then both the divisor and the quotient are factors. All right, so say you have this example. It says, determine if 2x squared plus 1 is a factor of 6x cubed minus 4x squared plus 3x minus 2. All right, so what you need to do is you need to divide 6x cubed minus 4x squared plus 3x minus 2 by 2x squared plus 1 and see whether or not the remainder is 0. So you're not just dividing, you're trying to answer the question whether or not it's a factor. But we do have to do the division, and here we have to do long division because we're dividing by 2x squared. We can't use synthetic division unless you're dividing by something of degree 1. All right, so this is good practice for long division. So ask yourself, what times 2x squared will give me 6x cubed? That would be 3x, so we put that up on top. Multiply, so we have 6x cubed plus 3x. Now notice here that I've lined up the like terms together. If I put the 3x under the 4x squared, that would not have been a like term. I wouldn't have been able to add or subtract those. Now if it's helpful, instead of dividing by 2x squared plus 1, you can put in 2x squared plus 0x plus 1 if you might find that helpful instead of trying to figure out where you have to skip a place and make sure you're lining up like terms. But really the reason that we have to do this is because we are quote unquote missing that term in the divisor. All right, so subtracting, we end up with negative 4x squared. That 3x and the minus 3x cancel, bring down the minus 2. And then let's do division one more time. So what times 2x squared will give me negative 4x squared? That would be negative 2. We multiply, so we have negative 4x squared minus 2. And we subtract, so change those signs, and this ends up being 0. So because the remainder is 0, we know that 2x squared plus 1 is a factor. In fact, we also know that 3x minus 2 is a factor as well. So both whatever you're dividing by, so the divisor, and the quotient, your answer, will be factors if the remainder is 0. Okay, so the remainder theorem is useful if you don't want to have to do a lot of division, but this only works when you're working with something that you could have used synthetic division on. So if a polynomial f of x is divided by x minus c, so it's a degree 1, then the remainder is f of c. So why do we have to use this if we could just use synthetic division? Well, sometimes you might get a problem, let's say like this one, x to the 79th plus 3x to the 24th plus 5. Even with synthetic division, this would become very, very tedious, right? Because you're missing x to the 78th to the 77th to the 70, all the way to the 24th, and then all those terms in between from x to the 24th until you get to 5. So that's a lot of zeros to have to deal with. And if you just want to find what the remainder is, well then, you only need to use this remainder theorem and plug in c. In this case, c is 1. So, using this theorem, we can plug in f of 1. That's 1 to the 79th plus 3 times 1 to the 24th plus 5, and that tells us that the remainder will be 9. Now, obviously, this doesn't tell you what the quotient is, but knowing what the remainder is most often more useful than necessarily knowing the quotient. Now, if you wanted to know what the quotient was, you'd absolutely have to do the division itself. All right, find the remainder when 3x to the 4th minus 8x squared plus 11x plus 1 is divided by x plus 2. All right, so we're going to use the remainder theorem. We want to know what the remainder is without having to do out the division. So using the remainder theorem, we would plug in negative 2 in for x in our polynomial. So this would be 3 times negative 2 to the 4th, make sure you put that in parentheses, minus 8 times negative 2 squared plus 11 times negative 2 plus 1. So that would be 3 times 16 minus 8 times 4 minus 22 plus 1. So that's 48 minus 32 minus 22 plus 1, which is equal to negative 5. So our remainder is negative 5. Again, this doesn't tell you what the quotient is, but if you're only asked to find the remainder and you don't need to know what the quotient is, then you can use this remainder theorem to find the remainder. Lastly, we have the factor theorem. Now, the factor theorem is very much related to the remainder theorem. It's just one step further from the remainder theorem. So the remainder theorem told us how we can easily find the remainder, and the factor theorem says, well, if you do that and you end up getting 0, then you know it's a factor. Okay, so a polynomial function f of x has a linear factor x minus a if and only if f of a is equal to 0. So the process here is actually going to be exactly the same. It's just a matter of, well, if you get 0, then you know this is a factor. So take a look at this last example. Show that x minus 3 is a factor of x cubed minus 4x squared plus 2x plus 3 by using the factor theorem. So using the factor theorem, we're doing it exactly the same as we did with the remainder theorem. You're just plugging 3 into our polynomial. So we have 3 to the third minus 4 times 3 squared plus 2 times 3 plus 3. This comes out to be 27 minus 36 plus 6 plus 3, which is equal to 0. And so now, because you end up getting that this is equal to 0, well, that means the remainder is 0, and therefore x minus 3 is a factor. And that's it. So notice that the factor theorem is really just the remainder theorem with one extra thing, saying that if you end up getting a remainder of 0, then you know it's a factor.